In this fifth video lecture, we will learn about group differences, effect size, and meta-analysis. Part 1 explores group differences. You can see here from the graphic what group differences is about. You have two different curves. One curve, the one on the left, is the control group. The curve on the right is the psychotherapy group. And what we want to know, especially if those two curves are normally distributed, meaning they both follow the normal distribution, whether or not the means are different between those two groups, the averages. If there is a difference, and if that difference is unlikely to happen by chance alone, we could say that there are significant differences between those two groups for whatever variable it is that we're measuring, say, depression symptoms. And that's useful in research because we want to ascertain whether or not there's a difference between people who get, say, CBT than people who don't get it, whether or not they are less depressed. So how do we figure out whether or not there are differences between those two groups, say CBT or a waitlist? Well, we use something called t-tests. T-tests are statistical procedures for determining whether a group's mean is statistically different from another group's mean. If we have a treatment and a control group, we can determine whether the independent variable had an effect on the dependent variable compared to no independent variable. So for example, CBT, if that's the independent variable, whether that has an effect on depression symptoms compared to no independent variable, so a waitlist versus actually having CBT. If this difference is statistically different, we can claim causation, because remember, whenever you have two different groups, that one of which is a control group, controlled comparison, and people have been randomly assigned to one of those two groups, you have a true experiment or a randomized control trial, and that eliminates the effect of confounding variables because of the controlled comparison and the randomization. And therefore we can say with more confidence that the finding is unlikely to occur by chance alone and unlikely to occur by confounding variables. T-tests can be run for both between group designs. So, for example, CBT versus placebo, here we have two different groups of people, two different samples being compared to one another. Or within group designs, for example, pre and post. Here we have the same group of people, the same cohort group, if you will, being compared at two different time periods, so before they receive an intervention and afterwards. It's the same people being measured twice. Between group t-tests are known as independent or unpaired, whereas within group t-tests are known as dependent or paired. Here's an example of a between group design, also known as independent or unpaired means. Here we have our intervention group, which is CBT, and our control group, which is no CBT, or waitlist, and dependent variable, which is depression scores using the Beck Depression Inventory. Here is an example of a within group design. We just looked at between group. This within group is for dependent or paired means and is also quasi-experimental because it's looking at the same group being measured twice, and therefore you cannot randomize people between groups. You cannot have a control group. Your control group is basically the same group being measured twice, but it's not a strong control group and there's no randomization. So the within group design is usually quasi-experimental. The independent variable for both is CBT, since both you have the same group getting CBT. The same dependent variable, depression scores, on the Beck Depression Inventory. The time is different, so we have pre-treatment and post-treatment between two intervention groups, and that's the data that we'll be comparing with one another. The values of a t-test are determined by degrees of freedom, and this is very much influenced by sample size. Degrees of freedom is calculated by taking the total number of participants in a study between all the groups in the study, so adding all those up, getting the total number of participants, minus the number of groups, So if you have two groups, that would be -2. And if you have a sample rather than a population, you have to always minus another 1, because there's always an assumption of error whenever you are measuring a sample rather than a population. And you can see here that when you -1 and you have, say, 30 people in a sample, that's going to have that -1 is going to have a much bigger impact on degrees of freedom versus 1,000 people in a sample, because instead of going from 30 to 29, which is you go from 1,000 to 999, and that difference in the latter example is far smaller, 1,000 to 999, than is 30 to 29. So you can see here that the sample size does impact the kinds of degrees of freedom that you're going to have. And as you'll see, the degrees of freedom impacts the size of the t-statistic, which tells us how significant something is. There's kind of a knock-on effect. And the important thing to take away from all this is that the sample size matters when you're doing what's called inferential statistics using t-tests. Inferential statistics is all about understanding whether there are differences, for example, between groups. If the t-value is large enough, it becomes unlikely to occur by error alone. These differences are considered or called statistically significant. For example, less than 5% likelihood of occurring by chance or error, and are written as, I'm going to give you two examples, t, the first example, with a degrees of freedom of 33, that's in the parentheses there, you always find degrees of freedom immediately following the t, equals 5.65 with a p of less than 0.05 two-tailed. This means that there are 36 total people in this study, because we have two groups, so 36 minus 2 is 34, and we have a sample, so minus another 1, that gives us 33. So of 36 participants, you have a degrees of freedom of 33, equals 5.65, that's our t-statistic. It's a nice number, but it doesn't mean anything at the moment, with a p of less than 0.05. Now it means something. Now what we're saying is that 5.65, that difference, is unlikely to occur by chance alone. It's unlikely, less than 5% likelihood that we would find this just by chance alone, therefore it is significant. Those differences are significant. And it's a two-tailed test, meaning we weren't sure whether or not we would find differences greater or smaller. So we weren't sure, for example, whether an intervention is going to increase or decrease a particular value in a person or a group of people. Remember, in most counseling studies you used one-tailed tests because it's unethical to say things like, well, CBT might make people more depressed, but if you are doing a two-tailed test, a legitimate one, then that's what that means. You're looking at both sides of the curve. The second example is t of 33, degrees of freedom of 33. And remember, that means we have a sample size of 36, minus 2 for groups, minus 1 for it being a sample rather than a population, equals 5.98 with a p of less than 0.01, one-tailed. That means that we have a t-statistic of 5.98, doesn't mean a whole lot until we get the p-value, the probability value, which is less than 0.01, meaning less than 1% chance of occurring by chance alone. And it is a one-tailed test, meaning we're just looking at one side of the curve. This would be the case if we were doing a CBT versus waitlist study, because we would expect CBT to cause less depressive symptoms compared to waitlist. Now we've looked at t-tests, we also have to understand chi-square, which is not that much different than t-tests, but is used in particular circumstances. Chi-square tests are used similarly to t-tests in that they are used to determine whether one group's mean is statistically different from another group's mean. Chi-square tests are used when t-tests cannot be performed because, and there's two major reasons. The first is to do with whether a value is string or categorical. If you have nominal groups, for example, men versus women, that's like a 0 or a 1 or a 1 or a 2. There are only two possible values you could have there, rather than a string variable, for example, scores on a depression instrument could vary from 0 to 50, say, you have to use chi-square because just having two possible data points is not going to get you the normal curve. And you really have to emulate the normal curve in order to do t-statistics, or t-tests. So that's the first case when you'd use chi-square. The second case is when the sample for the two groups is too small, and this leads to having a sample that does not adhere to a normal distribution. As I just mentioned, you have to have a sample that basically follows the normal distribution in order to do t-statistics. And that is going to be influenced by whether the scaling is correct, whether you have a string variable, and whether the sample size is large enough so that you're going to emulate the normal curve. If you don't have those things, if you have a data set that is not normally distributed, you are doing what's called non-parametric statistics, which is a very off-putting and complicated term that just basically means that you can't use things like t-tests. We cannot make, and this is why it's called non-parametric, because we cannot make reliable comparisons to the population and thus cannot generalize findings. Remember, populations are presumed to usually follow the normal distribution, and if you cannot have if your sample does not resemble the normal distribution, you cannot make the assumption that those findings from the sample are therefore going to be generalizable to the population. So you can't say, for example, that in my study of people who received CBT who were less depressed, I could make the assumption that all people in the population who receive CBT versus a waitlist will be less depressed. You can't do that if you do not have a large enough sample size, or if you are gathering information from categorical non-string variables. So in those cases we would use chi-square rather than t-tests. So we've talked about statistical significance and how you would evaluate group differences using t-tests. Next we're going to look at effect size, which is very important to statistics because it helps us understand what those differences mean, how big they are, how large they are. Here's a graphic that will help us understand this. Here we have a control group and an experimental group, kind of similar to before. We could have, say, CBT versus waitlist if you like. And both, as you can see from the graphic, resemble the normal distribution. They're both the same curve, they both look like they're normally distributed. So we can infer here that we can use the t-statistic. But let's say we got a significant t-statistic. Well, what exactly does that mean besides it being less than 5% likely to happen by error alone? Well, in order to understand how big the statistic is, we compare means and standard deviations to get an overall size of the effect. If you look at there's a kind of a basic equation on the x-axis that says difference of means. It's basically looking at the difference between the experimental and the control group mean, and we have a 70 minus 50 equals 20. That's the difference in means between the two groups. We also need to know the standard deviation for the two groups. And remember, when you have two different samples that both follow the normal distribution, you really only need to gather standard deviation from one of them since they're both going to have the same standard deviation. That's not, in actual statistics, it's very uncommon though for you to get exactly the same, so you tend to get what's called pooled effect size, so basically adding up both standard deviations and getting a pooled number. But just for the purpose of simplicity here, we have 50 minus 40 equals 10. That's our standard deviation. So we have a standard deviation of 10 and a difference in means of 20. Okay? So whenever you have those numbers, you can do effect size, which is 20 divided by 10 equals 2. So an effect size of 2. So what does that 2 mean? Well, we're going to find out. We have to understand why this is important in the first place before we get to what that 2 means. The APA Publication Manual, 6th edition, says, "For the reader to appreciate the magnitude or importance of a study's findings, it is almost always necessary to include some measure of effect size." Effect size is very important when you are reading a research study. And if they just report to the t-statistic and the probability value without reporting what that value actually means in practicality, then they're not doing you justice, because they're not telling you how big that effect size is, how big the difference is. It needs to be reported in all studies. So let's look at group differences, kind of going back to our prior example to understand what effect size means. Remember our intervention group and our control group, CBT versus no CBT or waitlist, for depression scores using the Beck Depression Inventory as our dependent variable. Even if we can determine that CBT caused change in Beck Depression Inventory scores compared to a waitlist, and determine that that change was less than 5% likely to happen by chance alone, it is unlikely that 100% of the reason for the change in those scores can be attributed solely to CBT. Therefore, we need to know, well, what percentage of that change is likely to happen just by CBT versus waitlist versus other factors. Put another way, regardless of whether a t-test might be significant, the amount of variance attributed to the model or size of the effect might be very small, very large. In other words, you could have something like the treatment, so CBT versus waitlist, that causes changes in depressive symptoms, but that treatment approach plays a quite small role in the reduction of depressive symptoms, because one of the samples, say, was taken from Seattle and another was taken from San Francisco, and the people in Seattle felt a lot less depressed over time than the people in San Francisco for whatever reason. And so that confounding variable really much better explains why you found differences between those two groups rather than the actual treatment approach. So in other words, even though there's a significant effect for treatment approach, it's not really that important in the grand scheme of things. And that's what you want to understand, is how important is that treatment approach in terms of why depressive symptoms reduced. Okay, so in order to ascertain how big an impact that the treatment approach had, we use what's called effect size. Now for t-tests, we use Cohen's d, the d statistic. And you'll see there are 4 boxes in front of you that show the difference in how large an effect size is as we have 2 curves that get further and further apart. The first curve, 2 curves on the top left box, has a d of 0.5. So those 2 curves are quite close together. At d of 1, those curves start to separate out. D of 2 even more still, and D of 3 even more still. And what you want when you have 2 groups that you want to show differences is for those 2 curves to be quite far apart, because it shows you that there are quite large differences between the 2 groups. Whereas curves that are quite close together, it shows you that there really aren't large differences between the 2 groups. So Cohen's d is used to compute effect sizes for t-tests, and we use the following guidelines to determine the size of an effect. A small effect is 0.20, a medium effect is 0.50, and a large effect is 0.80. So your 4 graphics that we just went through, the 0.5, 1, 2, and 3, those are more extreme examples, since we started with a medium-sized effect, and then 1 is more than a large-sized effect, 2 and 3 are huge-sized effects. Whenever you have a d of larger than 1, you have a very good-sized effect. So we're going to practice a little bit, interpreting what d of 0.37, d of 0.62, and d of 2.11 means. I want you to pause for a second and try to guess at what those statistics mean. So take a moment and do that. Okay, so a d of 0.37 means you have an effect size that is between small and medium-sized effect. D of 0.62 is a effect size that's slightly more than a medium-sized effect, though not a large effect. It's again almost between the two, but not quite. And then a D of 2.11 is a very large-sized effect. Here is the table that we typically use to ascertain or evaluate effect size. You'll notice if you scroll down the table you get to Cohen's d, which is used for t-tests, and again it shows you 0.2, 0.5 and 0.8 as small, medium and large. Other effect sizes that you will need to know, and you should probably have a table like this handy if you're doing research, is Pearson's R, that's the very top effect size, the one at the very top of the table. This is used for correlation and has a effect size of 0.1, 0.3 and 0.5. Those are parameters for small, medium and large. ANOVA, which is usually determined by either eta squared or omega squared, just depending on the type of ANOVA that you're running. Analysis of variance, you'll learn about this in a subsequent video lecture. 0.01, 0.06 and 0.14 are the most commonly used, although eta squared can also be 0.02, 0.13 and 0.26 depending on the type of ANOVA that you are running. Those are important to remember too, and you'll notice that those values are quite different, and so you cannot always assume that the effect size is what it means is going to be the same across different statistics. They can be quite different depending on the statistics, and that has to do with basically the formula for how those statistics are determined. So now that you understand what t-tests are and what effect size is, we're going to look at how those are written in actual formal reports and how you would write them in a formal report and what those things mean. You tend to, in APA style, write in fairly formal language. So with this descriptive statistics, which really has to do with measures of central tendency, we have an example statement from a study about youth mentoring. Youth being mentored ranged in age from 14 to 19 with a mean of 15.37 and a standard deviation of 1.15. This means that there was an age range for youth of between 14 to 19 years old. There was an average or a mean year age of 15.37 years and a standard deviation of 1.15 years. Okay, so if you were to go 2 standard deviations from outside the mean, you would have 1.15 plus 1.15, which is 2.3. So 2 standard deviations below 15 would be 13, pretty much, 13.07. And 2 standard deviations above the mean would be, if I can do my math right, 17.67. So that gives you an understanding for what it means to have those 2 standard deviations, and remember 95% of people are going to score between 2 standard deviations. So that's descriptive statistics, which in themselves are quite important, but they don't necessarily help us to determine whether there are differences between groups. Okay. Next we're going to skip down to the last example. We're not going to look at the correlation example since we haven't gotten to that in our video lectures yet. If you go down to inferential statistics comparing groups, it says as an example statement from a study comparing 2 note-taking interventions, partial graphic organizer, GO, and complete graphic organizer. So you have a study of students using graphic organizers. It says students who received the partial graphic organizer notes mean equals 138.62, standard deviation of 11.94, scored higher on the quizzes than did students who received the complete GO notes. Mean equals 133.13, standard deviation is 12.40. Let's stop there for a second, press pause. Basically what this means is that if you look at those 2 means, there is a difference in means, 138.62 versus 133.13. One mean is higher than another. And the standard deviation is somewhat comparable, 11.94, 12.40. We'd need to know whether this emulated the normal distribution, but at the moment it looks like at least the standard deviations are comparable, which is useful when you're comparing means. So now we have to understand whether or not those differences are significant or not, because 138 versus 133 could be large or small, just depending on the sample size, and also depending on what how most students are scoring. So we have a t-value with an a degrees of freedom of 112. So let's kind of recall what 112 means. Remember, you have total number of participants, and then you have to minus the number of groups, and then minus 1 for sample size. Well, if we plus 1 for sample, because we're using a sample, not a population, we get to 113. And then we plus 2, because we have 2 groups, we get to 115. So we have 115 total participants in this study, okay, with the degrees of freedom of 112. That's a decent degrees of freedom, a decent sample size. We have a value of a statistic next, 2.41. So that's the t-statistic, 2.41. That's not a huge t-statistic, but we don't necessarily know whether it's significant or not, if it has any meaning, without looking at now whether that is less than 5% likely to happen by chance alone. And the next statistic says p is less than 0.05, meaning the probability value of the statistical test is less than 5% likely to happen by chance. So that means we have a significant finding. There are significant differences between these two groups. Still, we don't know how big that difference is. There are less than 5% likelihood those differences would be found by chance alone. Great, but what does that actually mean? How big are those differences? Next we have the d statistic. D equals 0.45. This is Cohen's d. This is used for t-tests. This means, if you go back to your parameters of d, that we have an effect size that is between a small and medium-sized effect approaching a medium-sized effect. So not only are those differences between the two groups unlikely to happen by chance alone, they're also fairly large in size. They're a medium-sized effect, close to a medium-sized effect. And that means that this study has shown that there are important differences that exist between students who have a partial graphic organizer rather than a complete graphic organizer. Those are the kinds of ways that we would interpret statistics if we found them in a research study, and when you are reporting your own statistics, that's the way that you should be reporting them, in kind of a sentence format, one after the other, and then you explain what each of them means after you've given them in that sentence. You can look at your APA publication manual if you would like more examples of how to report statistics like this. So now we've looked at t-tests, the group differences, as well as effect size. We get to something very exciting, which is meta-analysis. Meta-analysis is a way of comparing the results of several studies. So in the graphic you see in front of you, we have 4 studies to determine an overall size of the effect. So for example, let's say we want to know whether CBT reduces depressive symptoms. We could do one study into that if we wanted to, one experimental study, and determine whether or not it caused a reduction in depressive symptoms, and if we found significance and we found a decent sized effect, we would be happy. But in the grander scheme of things, if you're making big policy decisions, you don't necessarily want to rely on one study. You want to look at replications. You want to look at, okay, what if other researchers did the same study? Would they find the same things? So when you compare those results together, you get a much stronger sense for whether CBT really does reduce depressive symptoms versus a waitlist. And that's overall effect size is known as meta-analysis and is given a lot of weight in the counseling and psychotherapy literature, as well as most fields. If you recall from your very first class, we had talked about how in psychotherapy Meta-analysis is the pinnacle of empirical research because we tend to most value research that pulls together multiple studies, especially randomized controlled trials or true experiments, to determine how big the size of an effect is. We have control and we have randomization, remember, in a randomized controlled trial. And if you use multiple versions of that and then compare the effect size, you have a fairly robust finding. So meta-analyses are at the very top of the research hierarchy in terms of the kinds of research evidence that we give the most weight. So meta-analyses are important studies, and these are computed by pooling together the results of individual quantitative experiments for the effect of the IV compared to control groups and compute overall effect sizes. Effect size, remember, especially for t-tests, is computed using the D statistic. Meta-analysis effect size is typically indicated by a D plus statistic. Meta-analysis has been very important in the history of counseling and psychotherapy, particularly the history of research in counseling and psychotherapy. Two examples of this. In 1977, Smith and Glass, and Gene Glass is pictured there, found that psychotherapy was more effective than no intervention in 75% of cases thanks to meta-analysis. This may seem expected or common sense to you, but at the time, the effectiveness of psychotherapy was being questioned, and so having a meta-analysis compare the results of multiple studies that compared psychotherapy versus no psychotherapy or alternative therapies for the treatment of mental disorders found that in most cases it's 75% effective, and that's very important to kind of justify, vindicate our profession. 20 years later, Bruce Wampold's meta-analyses determined that effective or quote-effective treatments, such as CBT, are only marginally more effective than other interventions once confounding variables have been controlled for. For example, allegiance bias. An allegiance bias is when you have the same theorist as being the researcher. So the researcher is basically evaluating their own theories against others, and as you might imagine, there is the impact of bias there, because if you are, say, Fritz Perls, the founder of Gestalt therapy, and you are wanting to know if your therapy, Gestalt therapy, is more effective than, say, person-centered therapy, you're probably more likely to favor your own therapy since you developed your own therapy. This has been a frequent criticism of a lot of research trials because they tend to be conducted by the theorist, or the theorist plays a role. So once you get rid of those studies, and once you just look at the studies conducted by independent researchers who don't necessarily have a strong allegiance to the theory, you do not find significant differences between different interventions. This was a huge finding because a lot of the research that's been conducted into counseling and psychotherapy, a lot of the grant monies awarded for that research, have been funneled into efforts that have compared one therapy versus another. And Bruce Wampold found that really that line of research is silly and pointless, since all of those modalities are effective, and equally effective really with one another. There's no massive difference. This was called the dodo bird verdict in what was known as common factors research. Common factors looked at what really is the difference between effective and non-effective approaches to counseling, and we'll see a graphic of that in a moment. The dodo bird verdict is kind of a fun idea. It originates from Lewis Carroll's Alice in Wonderland, where you have the dodo bird who, in part of the story, is evaluating a group of people who run in a race. I think there's just a variety of characters who are meant to be running in a race, and none of them reach the finish line. They run around in circles, or they run the opposite way, or they do all kinds of interesting things. And the dodo bird claims at the end of this race, no one actually reaches the finish line, all have won and must have prizes. What that means is all approaches are equally effective, and all deserve respect among each other, rather than saying that one should be the favored approach for a particular disorder. So we shouldn't, what that means is we shouldn't be saying CBT should be used for, say, depression versus, I don't know, person-centered. Instead, what we should be saying is any approach would be fine and is going to be equally effective, and each approach deserves respect. And I think that's a really important finding in the counseling field, because before then we were really engaged in what's called schoolism, which was essentially trying to downgrade or reduce the importance of one theory in relation to another. This is the graphic for common factors research. It essentially looks at what causes clients to get better, what has an impact on outcome. The yellow circle in the top left, if you look at the total circle, that circle represents why change happens, why improvement happens. Okay, the yellow shaded area of that circle is represented by client or extratherapeutic factors, meaning out of 100% of the reason for change, 87% of that is attributed to the client or extratherapeutic factors outside of the counselor's control. And this is a very important finding, because it tells us that in counseling and psychotherapy that the vast majority of the reason why people change, why they get better, is not necessarily to do with the counselor. It's not necessarily the counselor's responsibility or due to anything that they're doing. It's more to do with the client, their readiness for change, their ability to attend sessions, their ability to implement what they're learning in their daily lives, as well as extratherapeutic factors, for example, whether they've just experienced job loss, or whether they've just got married or had a child, or whether they have the money and resources or the education level to comprehend or to use what they're learning. So all these extra factors outside of the counseling relationship are going to impact how well a client does in therapy. Of the factors that are considered treatment effects, meaning things that you can actually influence as a therapist, only 13%, this is a very small proportion of whether or not a client gets better, that you can have an impact on, very small proportion of that. Of that 13%, the largest circle of that small, but you can see there's a small, looks like a greeny blue blob in that large yellow blob on the top left that is kind of broken down. So they show you a much larger circle now that kind of breaks down each part of that small blue-green circle. So the largest there is therapist effects, 46 to 69%. That means that who you are as a therapist matters. The kinds of approaches that you have, the kinds of person that you are, how warm you are, how flexible you are, all of those kinds of issues, how personable. The next largest is alliance effects. This is also known as the relationship. Alliance has to do with basically shared collaborative goals as well. So your ability to collaborate with the client, form shared goals, have a working alliance, that's known as a therapeutic relationship. And then next you have model or technique delivered. This has to do with expectancy and allegiance to the rationale and ritual. This is a very important concept in counseling. It's basically, what it means is whatever theory or interventions you are using, you need to believe in them. In other words, you need to have allegiance to them. And the client needs to believe in them too. They need to have expectancy that change is going to occur. This is far more important than that small green circle, which is the model or technique. The model or technique doesn't really matter that much in relationship to how much you and the client believe that it's going to help. So if the client, for example, doesn't believe in CBT and you don't either, it's not going to be effective, whereas if the client and you believe in, say, psychodynamic therapy, it's going to be much more effective. We also have feedback effects as the red circle there, and that has to do with how you can improve your practice by gathering feedback from the clients and adjusting what you're doing. So here we find a really important finding from research, which is what really matters in counseling and how you can best adjust what you're doing or best serve the client by focusing on the most important things, which are who you are as a therapist, how you build relationships with clients, especially collaborative relationships based on goals, how you and the client must believe in what you're doing, how you must gather feedback from the client, and then last on that list is what techniques, what specific model you choose. So a simpler graphic, if you want to know the more specific percentages, are, in terms of that 13%, because 46 to 69% of 13% is quite confusing. If you do the math, the therapist accounts for about 6 to 8% of the total outcome, the impact on outcome. The alliance or relationship is 5 to 7%. The expectancy and allegiance accounts for about 4%. And then the model or the technique only accounts for 0 to 1%. 0 to 1%. And we've spent the last 50 plus years with really focusing our attention on one intervention versus another and comparing them, even though only 0 to 1% of the impact of those interventions, there's only a 0 to 1% impact in terms of whether clients get better or not. It seems like a vast over expenditure of resources compared to the therapist, by which we know very little, by the way, in terms of what makes an effective therapist versus a non-effective therapist. Even the relationship or the alliance we know comparatively little about. So I think what you're going to find over time now is there are going to be more studies that examine the impact of the therapist and the alliance versus just the model and the technique. These numbers don't precisely add up to 13%, and that's because you have some degree of variation. And also you can see, if you go back to the prior graphic that we were looking at, some of those circles overlap, and that's why they don't completely add up to 13%. Now remember, even therapist impact, which is 6 to 8%, is tiny compared to the client impact, or the extratherapeutic factors impact, which is 87%. And I think in the end we're going to be, if we were really doing research with any kind of legitimacy in today's environment, we would be looking at what client factors impact outcome and how we would address that. So this is the more simpler graphic just to show you, if you were to just have one chart, one pie chart, the client here in blue and extratherapeutic factors is by far the biggest impact on client outcomes. The therapist, the red sliver, is next. Then alliance or relationship is the green sliver. Allegiance or expectancy is the purple sliver. And model or technique is that tiny light blue sliver. So we really should be focusing most on the client at this point, as well as what we can control for, which is the therapist, the ourselves, the alliance, the relationship, and the allegiance and expectancy in the model. And the model and technique itself really is not that important in the grand scheme of things. So we've reached our review. Today we learned about group differences, effect size, and meta-analysis. This concludes this video lecture.